हाँ शुरू कर.
In pipelining, when an instruction has to be executed, it has to go through 5 stages. First stage is fetch, second stage is decode, third is execute, fourth is memory, and fifth one is write back. Without pipeline, when an instruction is the instruction has to go through all the 5 stages which I have mentioned, but until the instruction 1 has not finished its last state, instruction 2 cannot enter and cannot be fetched. This takes greater number of cycles. It has less speed. The efficiency is decreased in it. So, as we know that or nowadays, efficiency and speed they are most important resource. All the updates that we find in our mobile phones, in our laptops, that are due to that the reason or process behind it, so that the speed can be increased, efficiency can be increased, time can be decreased. So to encounter this problem, as you can see, as you can see in this one as well, that these color code represent different type of fetch stages. Like the first one is fetch, and second little bit dark green color is decode, then it becomes more green, that's memory, then it's execute, then it's write back. As you can see, the after write back is done, at beneath that a new instruction is fetched behind it. Until one instruction has not gone through all the stages and it's finished execution, second instruction which is waiting, it can't be executed.
For that we use the pipeline. Wait, this is a pipeline. When the instruction 1 is in the decode segment, the second instruction is already in the fetch state, and it happens continuously. Like when this instruction is in the decode state, the next instruction is already in the fetch state, and this increase the speed. And we're going to show you how we use the CPU simulator. So when you open the CPU simulator, it will be like this, and it might tell you to press escape first, and you'll see this interface. First of all, you'll go to compile. To load a program, you have to follow these steps. You have to go to compiler, and you see this let me make it big. Okay, so you see this yellow area, and you have to paste the code. Now the code is already be provided in LabJ. I mean the exam. So it accepts many type of languages like C, C sharp, C++, Python. We are going to use Python. So I have already copied the code from this LabGen. Wait, let me show you. This is the code. Okay, kidhar gaya? This is the code. I have copied it already. We'll paste it here, and then uh, we'll go and compile, and we'll compile the code. When we compile this code, it creates a assembly language code by itself uh, using this code. And to run this code, we just have to click on run. Now the code is executing, and now to see the pipeline, you have to go to this. That screen will already that screen will automatically close. You have to go to show pipeline. Now right now the pipeline is not, it is the pipeline is not on. As you can see, when the above instruction leaves the stack, then the next instruction enters the stack, and the speed factor is 0.9798. And the CPI is clock per क्या था अब्दुलरमान? Clock per
CPI is
instruction.
clock per instruction.
Yeah, it's clock per instruction, and it is inversely proportional to speed. The higher the speed factor, the higher the speed, higher the efficiency. But the lower the higher the CPI, the lower the performance. So we are going to uncheck no instruction pipeline. This uncheck will trigger the pipeline, and now as you will see that the CPI is decreasing and the speed factor is increasing, and the execution are happening fast. This is sorry. And the higher the speed factor, better the performance. And this is all to the pipeline. You can see some different stages of pipeline happening. When the let's say when this instruction enter the decode state, the next instruction is already at the fetch. This increases the performance overall. And now we're going to show you the hazards. And there is another way to add the program. First of all, you have to write a name for the program. अब्दुलरमान ये डॉट के साथ आता था बगैर डॉट के?
यहाँ से
मतलब
मैं कर लेता हूँ,
हाँ बोल,
मैं ट्राई करता हूँ.
टाइप नहीं कर
If you
सकता
if
तो?
you want to
हाँ
upload
सही.
if you want to upload the assembly code in this program, first of all write program name. We are writing exe. At base address write 0, and then add press the button add.
Okay, I think we have to clear reset program या फिर दोबारा बंद करके खोल लें.
दोबारा
Okay,
बंद करके खोलो.
let's just reopen the CPU. Now the pipeline, the CPU simulator just turned on, and we are going to
To add an
program name
to add
exe.
an
Okay, cool.
to add an assembly code to this program, you have to first give program name, which is on extreme bottom of left side. As you can see the cursor on it, we are writing program name as exe. Write base address 0. Press the add button. Now you can see that the program is loaded into program list here at slot e slot. First of all, if you want to add assembly code, you have to go through step by step. Let's take a basic example. Like if you want to add two values R1 and R2, go to instructions, add new. Okay, here the here these are the different kind of statement. We are using move statement for R1. Add value, add give value,
Give
go to
value
value, give some
like
random value to value, 10,
value
20, then go to register. Not this one, the end one.
and one
Go to R1.
R1.
From here go to value, not register,
Okay,
and press the button new instruction.
now here you can see the instruction is added, and
The value 4 is added in R1 register. Now if you want to add another value in another register, like go to value, add 10.
okay, arithmetic में जाएं या इधर ही move में?
इधर नीचे जा रजिस्टर पे.
इस पे
ये वाला हाँ हाँ ये नीचे बिल्कुल जो नीचे वाला है, सबसे नीचे वाला.
हाँ सही है, इसको
हाँ
वैल्यू हाँ
यहाँ जा R2 पे.
R2, go to R2.
Press the instruction, new instruction. As you can see, it has been also been loaded. So now the now the time of execution is we want to add the values in R1 and R2. But before that, the thing we want to do is that we change the value of R1 from 4 to 10 or 20, which is desired by the user. Go to value,
Value
write 5.
5.
Go to register on top at the end, and not
And
this one, not this one,
this
and
one
this one. Yeah, yes, this one. Go to R1
R1.
and new instruction button. Press that.
Yeah,
I'm here. To up, to update the value of R1, we go to add new. Give value 5 to R1 in value slot.
R1
Here. Go to R1,
new instruction.
and press new instruction button. Press it. As you can see, the value in R1 has been updated. Now the next part is add function. For add, we go to arithmetic. Press you can do any of these. If you're going for add or multiply, let's go for multiply. Go for multiply.
Multiply.
Multiply. And go to register. This is the source one. Go into R1. go into R2 in second one
and add
and new instruction.
new instruction.
Add it. Yes. So as we know that in assembly language, when we do it at the end, we write the keyword end. To end this program, we will write the keyword HLT. But to obtain that keyword, we will go to um,
Miscellaneous.
um, control transitions.
Okay, control transfer
I'm
and
going to end HLT.
HLT, and I
HLT.
think there is no need to add
New
any
instruction.
register. Just add it, and
Any, just add it.
we just
After
created a
this,
program.
we have created a
Close.
simple assembly program in which the first R1 register had the value 4, R2 had the value 10, and R1 value of R1 is updated to 5. Then we are doing a simple multiplication between these two registers. To end it, we are using the keyword HLT.
Which is in control transfer.
To now close this.
I Yeah,
Reset program.
we are going to reset the
The
program
per
once there is an arrow, and when we reset the program, the arrows go here, and now the program will be executed from here to like here. So we are going to run the program, and let's see. Let's check the no instruction pipeline, because we are trying to check the hazards. And once first we are going to run this program without pipeline. So we are going to run it, and program ran. So the value 4, first R1 had the value 4, then R2 had the value 10, then the R1 value was updated to 5. They multiplied. As you can see, the R1 value is 5. Then this destination is on destination second way होती है ना अब्दुल
Actually, the second one, the
Yeah,
required result is correct because 5 times 10 is 50.
50. Now let's reset the program again, and let's run this with a pipeline. We are going to uncheck the no instruction pipeline, and the program is already reset. Run. अबे ये तो ठीक हो गया भाई. Okay, so we did a mistake. Do not insert bubbles. Bubbles are basically used for hazards. So we are going to let me show you what happens. So as you saw back then, the answer was 50. Let's reset the program again, and let's run it. Now there is a data hazard. The value is after multiplying the value is 40. Is because before even this, if when the this instruction of move is executed, the values are already multiplied due to the pipeline. To fix this problem, there are 3 ways that we are going to use. First is we are going to uncheck this do not insert bubbles. This adds one more cycle to the program, I mean to the thingy, and this basically eliminates all the hazards. So first of all, we are going to flush the program, and we are going to uncheck the do not insert bubbles. And we are going to reset the program again and run. Now the value is correct. Let us show you the pipeline. Now the last time the clock number was 16, now it is 17. उसके बाद क्या था रहमान? अच्छा, enable operand forwarding का सीन था ना? Setting. हाँ आप बोल. Speak. बोल लो भाई.
Basically, the purpose of bubble is to give a delay in is to give a delay in execution. And as you can see, the new type of color coordinate that is red. The red indicates that bubble. By the help of bubble, there's a delay of 1 cycle in it, in which the next instruction multiply value R1 register by R2 register. The value in R1 register can be correctly taken from it, and it has been updated before being multiplying. If you do not add the bubbles in it, it cannot be updated because mm, when the multiplication stage because when in multiplication stage because in multiplication stage the 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 instruction has already been fetched and the instruction move so that the value in R1 can be 5. It is not completed. It is in right passage, so the value has not been updated. That is the reason for that our answer is not as required, which is required by us, which is supposed to be 50, but unfortunately it is rose 40. This was the first technique to remove the bubble, to add bubbles in it, give a delay, and get your desired output. You can also call these bubbles as stalls. The purpose is to give delays. The next thing that you use in data hazard, that is NOP instructions. As we know that in bubble give a delay of one cycle and NOP gives delay of two cycles. It's extremely easy and it is convenient to use NOP to handle data hazard as well. It is an alternate way to do that. We will demonstrate in front of you. Hope that it will be clear to you.
Add new
Add new miscellaneous
NOP,
NOP new instruction.
and then we are
As you
going
can
to
see that as you can see that the NOP instructions, it is now at the bottom. To move it, because we need what do you call it? We need the loop or delay in after the move instructions so that the value in register 1 can be properly updated to obtain our mission to obtain the desired result. We will add NOP instruction above multiplication instruction. To move it up, as you can see the button below, move up. You're going to press it twice.
now the NOP is
This,
over.
as it must demonstrated that NOP has been moved two places upwards. Now reset the program
The
and
pipeline is on. The pipeline is on. We are going to execute the program, and this time the answers are correct. It should be 50, and the yeah, it's basically we just put the NOP and it removes the data hazard. Resumed.
now the third one is operator forwarding. And in that one, first thing you have to do is that delete the NOP instruction. You have to
We'll
delete
click on
it
that.
by clicking to the button, by clicking on delete button in it.
First, we'll click to NOP, then we'll go to delete, and NOP is deleted. Then we'll go to show pipeline. We are going to
Go to
uncheck
show
the
pipeline, insert bubbles in
do
it.
not insert bubbles. We are going to uncheck this, and then we will check the enable operand forwarding, and we're going to flush it one time. Reset the program so the arrow go here, run, and we can see that we removed the hazard and the answer is correct again, and this shows the forwarding thingy working, and we removed one more hazard, and there is one last way we can there is a way to optimize the program. We'll do that. I think शुरू कर अब्दुल
This is the code that we have obtained from the journal that is being given to us by ma'am regarding data hazards. Now the other step is to go to
Now
optimize
this is a
button.
fourth, and we are going to optimize the code. So first we are going to see when the code is not optimized, how the code looks like. First we are going to compile look. As you can see, it's pretty long. Many registers are used and many move statements are used. Now to optimize this, we are going to go to optimize. अब्दुमान आगे बता फिर स्ट्रेट कर.
Basically, to optimize our code, there's a few series of steps that you have to follow. The first one is um, On extreme right of compile button, go to optimize, enable optimizer, check the box and go down,
We scroll down in this.
optimize code dependencies. You have to click that, optimize code dependencies, go up,
Where? Okay. Remove
go
redundant
up,
code.
remove, check the box,
Check the box of remove redundant code.
compile it,
And then we are going to compile
compile
it to
it.
create the assembly code again. As you can see now the code is in like 3 lines and only three move statement are used. And the last time it was 5 6 lines. So we are going to run it.
Less number of registers is used, less memory is occupied. That was our task, that was our mission, which has been accomplished.
Okay
This is the end of
guys.
the data hazards fourth one. Got any
Okay.
query? We're there for you.